Assalamu alaikum. In this video, we discuss the second part of the chapter, Work and Energy. I recall the main points of this chapter: the work done by a constant force, the work done by the weight, the kinetic energy of a system, the gravitational potential energy, the mechanical energy, and the principle of conservation of mechanical energy. But in this video or in this part, we discuss the kinetic energy, the gravitational potential energy, and the mechanical energy. Let's define the kinetic energy. In simple words, the kinetic energy is the energy of an object of mass m due to its motion with speed v. To determine the expression of the kinetic energy or to determine the physical quantities that affect this expression, let's consider the following two examples. In the first example, we have two objects of different masses. We can see here the heavier object has more impact than the lighter object when they hit the ground. So we can say that the kinetic energy is proportional to the mass. And in the second example, we can see that the car with the highest speed has more energy because it becomes more difficult to stop it. So we can say that the kinetic energy is proportional to the speed. The expression of the kinetic energy is defined as Ke is equal to half mv squared, where m is the mass of the body in kilogram and v its speed in meter per second. However, to convert from gram to kilogram, we have to divide by 1000, and to convert from kilometer to meter per second, we have to divide by 3.6. Please pay attention for these special notes on some expression. When they say that the object is released from rest, it indicates that the initial speed of this object is equal to 0 and the kinetic energy is also equal to 0. And when they say that the object reached the highest position or it reached the maximum height of a rectilinear path, it indicates that its speed at this point is equal to 0 and then its kinetic energy is equal to 0. Let's solve application 3. We have a car of mass m and it moves with a speed of 72 km per hour. We have to calculate the kinetic energy. The expression of the kinetic energy is equal to half mv squared. We substitute, we have mass equal 1000 and we have the speed is 72. But we have to convert from kilometer per hour to meter per second, so we divide by 3.6 and the final answer is equal to 200,000 joules. Potential energy is an energy stored due to position or shape. It is stored in a system due to the interaction between the constituents of the system. There are two types of potential energy: gravitational potential energy and elastic potential energy. But for grade 12 SE, we are interested in gravitational potential energy. To define gravitational potential energy, let's imagine the following example. I carry a ball with my hand and when I release it, it falls down. This means that the ball initially possesses a certain amount of energy. This energy is called gravitational potential energy. So, gravitational potential energy is due to the gravitational interaction between the object and the earth. It depends on the height of the object above a reference and on the magnitude of the gravitational interaction. To determine the expression of the gravitational potential energy, let's discuss the following example. We have here two objects of different masses are falling down. We can see here that the impact of the heavier objects when it reaches the surface of table is more than the lighter objects, which indicates that the potential energy is proportional to its mass. And in this animation, we see that as the car moves down along the inclined plane, the height decreases So the potential energy as shown in the indicator is also decreases. So we can say that the gravitational potential energy is proportional to the height. So the expression of the gravitational potential energy is equal to plus minus mgh, where m is the mass of the object and its unit is kilogram, g is the intensity of gravity and its unit is meter per second square, and h is the height of the object with respect to a certain reference and its unit is meter. Also, it's very important to choose a reference level in order to determine the sign of the gravitational potential energy. The plus or minus sign in the expression of the gravitational potential energy depend on the position of the object with respect to the chosen reference level. If the object above the reference, then the gravitational potential energy is equal to mgh. And if the object is on the reference level, then the gravitational potential energy is equal to 0 since the height is equal to 0. And if the object is below the reference level, then the gravitational potential energy is equal to minus mgh, and in this case it is less than 0. Let's solve the following application. We have a box of mass m equal 500 gram falls down from point A toward point C. We have to calculate the gravitational potential energy of the system box Earth at point A, B, and C with respect to the horizontal plane passing through B. The expression of the gravitational potential energy at point A is equal to mgha. We substitute, we have mass equal 500 gram. It is equivalent to 0.5 kilogram. And we have the intensity of gravity is equal to 10 and the height is 1 meter, which is equivalent to 100 centimeters. So the gravitational potential energy at point A is equal to 5 joule. The gravitational potential energy at point B is equal to 0 since the height of the box at this point is equal to 0. And the gravitational potential energy of the box at point C is equal to minus mghc is equal to minus 4.5 joule. Now we discuss the mechanical energy. We consider the following example. We can see that the kinetic energy and the potential energy varies, but their sum is equal to a fixed point which is equal to 100 joule. So we can say that the mechanical energy is equal to the sum of the kinetic energy and the potential energy at any instant t. At the end of this second part, we summarize the main objective as the kinetic energy is the energy due to motion of an object of mass m and speed v. The expression of the kinetic energy is equal to half mv squared. The gravitational potential energy is the energy possessed by an object due to its position in a gravitational field. The expression of the gravitational potential energy is equal to plus or minus mgh. The sign of the gravitational potential energy depends on the position of the particle with respect to the reference level. And the mechanical energy of a given system is the sum of their kinetic energy and the gravitational potential energy. Thank you for listening and for doing all the recommended assignments.